Consider the following example. Bar AB has a weight of 250 pounds and all surfaces are smooth. Find the tension and forces at A and C. Whenever they tell you all surface of contact are smooth, this means that the force is perpendicular always to the contact line. Okay? So for example, if I consider contact at A, if I consider at A, the contact line is this one. This is the contact line. So the force is perpendicular to this line. This is the reaction at A. I will call it reaction at A. I also have a contact at C along, and the contact line is this one at C. So at C, I need to consider a force perpendicular to the contact line like this. I will call it RC. This is the reaction at C. And finally, I have a cable here. You know, a cable, sorry, a cable can only be subjected to tension. So I have the force from the rod towards the cable. This is the tension acting on the rod. So I have three unknowns in this problem, and I want to solve for my unknowns. So of course, I need to write three equations of equilibrium. My three equations of equilibrium are sum of x equals 0, sum of y equals 0, and sum of moment about any point that I select equal to 0. Okay? I can start first with sum of x equals 0. To be able to project RC on x, I need, yes? Yes?
Only if the surface is smooth, the reaction is perpendicular to the contact line.
No, yes, look, if the surface is rough, you need to add friction force. Yani, you need to consider the perpendicular to contact, but you need also to add the component of friction. Yani, here you can add a friction force, let's say like this. Okay? So you need to add, you will have two components of force, one perpendicular to contact, one parallel to contact. But here, since it's smooth, you don't include this force, okay?
Okay, thank you.
Okay. So now to be able to project RC, you need to consider the angle between RC and the horizontal line. So from your figure, this angle here is 50 degrees. And you have here a right triangle. Here it's perpendicular. So the angle between RC and the horizontal is 40. So this is 40 degrees. So now you can project RC along X and Y. To project in X, it's a negative X direction. So it's minus RC cosine 40. And to project on Y, you do plus RC sine 40. Okay. So now let us apply equations. Sum of X equals 0. What do we have? We have the tension T, so plus T, or they called it F here, plus F, and minus RC cosine 40 equals to 0. This is equation number 1. I move to my second equation. Sum of Y equals 0. I have plus RA, and for RC, we said it's a positive also projection, plus RC sine 40. Don't forget the weight, okay? So when you draw the free body diagram, the weight should be placed at the middle of your rod. So the weight is given to be 250 pounds. So you have minus 250 equals to 0. So your equation number 2 is RA plus RC sine 40 equals to 250. You still need to, you have three unknowns, you still need one additional equation. And here you have the freedom to select sum of moment about any point you want, A, B, C, okay? So here, there is no preference if you want, because we'll always have two unknowns. If I do sum of moments about A, I need to consider moment of F and of RC. Both will do moment about A. If I consider moments about, let's say, point C, okay, I will need to account for moment of F and moment of RA. So there is no equation that will give me directly one force. I need to select any point, okay? So here, for example, as I considered A, let us consider C to do another practice. So if I do sum of moments about C, if I want to do sum of moments about C equals to 0, okay? Let us see what are the moments to consider. First, I need to select a positive direction. So I write sum of moments about C equals to 0. And I can say, for example, let me consider the clockwise as positive. I start with this force, RA, okay? So to find the moment of RA about C, what is the technique? I extend the line of my force, okay? And I draw the perpendicular from C to this line to get the distance. The distance is this one, okay? This distance is equal to, if I look at my figure, I know that this is 2 plus 6, this is 8. This distance is 8. And this angle here is 50. So this perpendicular distance is 8 cosine 50.
50.
Yes? Yes, tell me. Who has a question?
While we calculate the moment, we don't consider the weight?
Of course we do. Of course we do. So now,
No.
when we will consider the moment of the weight about C, okay?
Can you have 3 unknowns or 2?
No, the weight is known. You know the weight. The weight is 250, okay?
Oh,
Yani you know the value, but you find its moment, okay? It will not add an unknown, but it will add a term to your equation, okay?
okay.
So you have plus first moment of RA plus RA times the distance, which is 8 cosine 50. Now, when you take the weight is known. And if you look at your figure, the weight is doing a moment in the counterclockwise direction about C. So you put minus the weight, which is 250, times which distance? Same method. You elongate the line of action of the weight. Okay? And you draw the perpendicular. This is the perpendicular distance. It's not clear in this figure anymore. I will show you, I will show it for you here. This is your weight. Okay, your weight is passing by this point, by the middle of your rod. Okay, what is the total length of your rod? 2 plus 6, 8 plus 4, 12. So this distance is 6. This distance is 6 feet. Okay. And what you want is just the distance from the weight to C, this distance. This distance is 8 minus 6, it's 2. So this distance is 2, okay? But I want to take not this distance, the perpendicular. So this is my weight, like this. I elongate this line. And I say, let me draw the perpendicular distance. This is the distance that I want here, this one. So since this is 2 and the angle here is 50 degrees, this distance is, the perpendicular distance is 2 cosine 50. Okay, I will draw it for you here again to be clearer. This is your 2 feet. Okay, the weight is here. And this is your point C. You elongate your weight and you say, I draw the perpendicular distance. To get this distance, you need this angle. This is 50 degrees and this is 2. So this perpendicular distance is 2 cosine the angle, okay? And since it's a counterclockwise moment, so minus 250 times 2 cosine 50. Okay, and finally, you still have to consider the moment of F about C. Okay, or C will not produce any moment because it's passing by C. You still need to consider the moment of F. To consider the moment of F, same method, you elongate your force, Let me choose another color to show it for you. So this is your fourth line of action. You project, you do the perpendicular from C to this line. This is the distance of interest, okay? And if you do with your hand, it's rotating about C like this. This is your force, and this is C. It's rotating about C counterclockwise. So also it's a negative moment. So minus F times this distance. This distance, okay, to know how to calculate it, you need to consider the distance between these 2 points, which is 6, times cosine of the times sine of this angle, because this side is opposing this angle of 50 degrees. So now this distance will be 6 sine 50. So minus F times the distance, which is 6 sine 50 equals to 0. So now this is your third equation. You end up with a system of 3 equations, 3 unknowns. You can solve for all of your unknowns. Okay. Question on this? Another example. The vertical pole DE is supported by cable DF. The tension in DF is 150 kilonewton. Determine the reactions at E, which is a fixity. Because E is a fixity, this means if I want to present it as symbol, it's like this. We said that the fixity can develop 3 types of reactions, 2 forces and 1 couple. So I have EX, I have EY, and I have a couple moment. I can assume a direction. So here, I can assume the couple to be counterclockwise. This is ME. Now, to solve for my unknowns, I need 3 equations. Keep in mind that you have a cable, but the cable here is not of unknown force. They gave you the tension in the cable. So you can just present this tension. The tension is acting from D towards the cable, and the magnitude is known, it's 150. And you need to determine EX, EY, and ME, okay? So you start to say, I can write my first equation as sum of x equals to 0. To be able to get EX, you need to project the tension force. So you need to know what is this angle here, okay? To calculate this angle, if you look at your figure, from the geometry of your figure, this distance is known. So you know that the distance here is 4.5. This distance is known, 4.5, okay? And this one in the vertical direction, you can calculate it. So in the vertical direction, you have 2.25 plus 3.75, you have 6 meters. So you can say that I can easily calculate this angle by saying that theta is tan minus 1 of this distance, which is 4.5 over 6. So 4.5 over 6. I get then my angle theta. And once I get theta, I'm ready to project. When I project my 150 kilonewton force in X, I need to do sine theta because this angle is opposing. So you hear me? Okay. So we were saying that first we need to project in X. If I want to project along X, what do we have? We have to consider this force sine this angle. So we have 150 sine theta. And this is the only force in X, okay? We have only still the reaction, so plus EX equals to 0. So we get a negative value for EX. You can expect this, okay? because the only force having component in X is the 150 force, and its component is positive. So you can, from the beginning, say it's clear that to oppose this force, EX should be to the left. So if you put from the beginning EX to the left, you'll get a positive result. But because we didn't consider this, we put it to the right, you will get an. So according to our assumption, we get a negative AX. Okay, if we take the opposite assumption, we'll get a positive EX. It doesn't matter. You can take the assumptions that you want, but stick to this assumption. Okay, so I will keep EX in this direction in my figure, but when I replace it after, I will replace it by a negative value. Keep this in mind. Okay, so I will not change anything on the figure, but I should remember that the X is negative. Now, second step, I can write sum of y equals to 0. If I consider sum of y equals to 0, I should project all forces along y direction. What do I have? Here, if I consider y to be positive up, I have plus EY, and you have minus 24 times 1, 2, 3, and 4, so minus 80 kilonewton. And you have also the downward component of this force, so it's minus 150 times cosine angle theta equals to 0. So this equation will give you the value of EY. You still need to solve for one unknown, which is the moment reaction at E. To solve for the moment reaction at E, you can do sum of moment about any point on your figure, okay? But the easiest point you can consider that the easiest point is E, if you want, okay? If I take E as my point, EX and EY will not do a moment about it. And also, you can say D is simpler also. Why D is simple also? Because the tension is passing by D. So you don't have to take the moment of the tension. And EY also is passing by D, so D is easier. Okay, you can take sum of moment about D equals 0. Let us do it. So we write sum of moments about D equals to 0. What do we have now? If you consider point D, okay? First, for these forces, the vertical forces, the distances are really simple. The first one, if you draw the perpendicular, and if you extend the line of the force and you draw the perpendicular, it's equal to this distance, this one, which is equal to 1.8, okay? So, and considering the counterclockwise direction as positive, all of these forces, the vertical ones, are doing counterclockwise moments. So you have the first force plus 20 times 1.8. If you consider the second force, the only difference is the distance. And you have this distance. Instead of just 1 times 1.8, you have 2 times 1.8. So you have plus 20 now times 2 times 1.8. So the distance now is 3.6 meters. For the third force, you need to add an additional 1.8 meters. So you have plus 20 times 5.4. And finally, for this force at A, the distance is 4 times 1.8, 7.2. So you should add plus 20 times 7.2. Okay? Now you are done with these forces. You still have to consider, as we said, EX, the moment of EX, and please don't forget the couple moment. The couple moment is a free vector. We need to consider it when we do sum of moments about any point in space. Okay? So since I assumed counterclockwise moment, I will put plus ME. So plus ME. And now I still have to take into consideration the moment of EX about D. To get this moment, let me say the following. This is my EX. Guys, it's true that you got EX negative, but on your figure, you didn't change it. So I will stick to this arrow, but when I replace EX in my equation, I replace it by minus 150 sine theta, okay? So I will keep EX in this direction, and I will say, if I take EX positive in this direction, what is its moment about D? This is the perpendicular distance. The perpendicular distance is equal to 6 meters. It's equal to 6 meters. And since I considered EX to be positive to the right, it's producing in this figure a moment in the counterclockwise direction. So it's a plus 6 times EX, okay? But now when I replace EX by its value, here I replace EX by my negative value because EX, I got a negative result, okay? So when you replace EX by a negative value, then you deduce that the moment is producing about D is clockwise, okay? So now I solve for my moment about E. The only unknown is my moment about E. I solve for ME, okay? Any question on this?
I have a question.
Yes, tell me.
If our assumption was right for EX, we replace its value positive?
Of course, because you will get a positive result when you solve your system. So you replace by the value that you got, which is positive.
Okay.
Okay? Another example. The 10-ton moving crane shown below has a mass center at C. It carries a maximum load of 18 tons. We want to find the smallest weight of counterweight C and also the largest distance D so that the crane doesn't tip clockwise when the maximum load is lifted and the crane doesn't tip counterclockwise when there is no load. What do we mean by this? This is a design problem, okay? You see these structures a lot in order to lift objects. And these structures should be carefully designed. Why? Because you have two extreme conditions. What are the extreme conditions? If I don't put any load, so if I'm not using my crane, I have zero load here, okay? If I have zero load here and I have a very large counterweight, my structure can tip over, yani it can turn in this direction because the counterweight will be able to create a high moment in the counterclockwise direction. And this will lead to, if you want to, this will make me lose contact with B. So I have the risk of losing contact with B and tipping over A. So in this first extreme condition, so if I have zero load, my crane can rotate counterclockwise and it will lose contact with B, so RB will become zero. This is the first critical scenario. The second critical scenario is if I put a maximum load here. If I put my maximum load here, I have risk of tipping over in the clockwise direction. And then I have the risk of losing contact with A. So RA will be zero, okay? That's why when I do the design, I consider what should be the minimum value of the counterweight. So what should be the minimum value of the counterweight to prevent, if you want, turnover when I have a maximum load? And what should be the minimum value of D? Okay. In order to avoid tipping over in the second condition. So I need to determine two things, smallest weight and largest distance D. Because when I have the case of zero load, I have the risk, if I have a very large counterweight, I have the risk of tipping over. So I have a certain minimum weight to satisfy. So I should find minimum possible weight. In the opposite case, okay, when I have a value, when I have maximum load here, if I have a maximum load, to avoid tipping over, I need to create an opposite moment from the other side. So I need to have, okay, a certain distance d, any way to prevent this tipping over. So we need to calculate these extreme conditions, okay, to not have tipping over of my crane. So to do this, okay, we need to consider the two extreme scenarios. Let us consider the first one. In the first case, okay, we said we have a risk of tipping over A. In which case I have a risk of tipping over A when I don't have any load here. So if I don't put any load here, okay, then the structure will tend to rotate from this side, okay? And I should select the weight and the distance in a way to prevent this. So I can say the following. What do I have in my figure? What are the forces acting on my structure in this case? I have the counterweight, and I have the weight of the structure, which is 10 tons acting at the center of mass. Plus, I have my reactions at A and B. Now, because I am working in extreme conditions, so in this first scenario, I take the worst case scenario of tipping over. I lost contact with A. If I lost contact with A, I will set RA to be 0. So if you want, let's say, increase my weight a little bit or increase my distance a little bit, I will have tipping over. So I'm searching for design conditions. I'm searching for what value of distance and what value of weight to not cause this tipping over. Okay.
دكتور بس احنا ليش we lose contact with A؟
You lose contact with A because when you want, if you with B in this case, okay, with B. If I take zero load, I lose contact with B. If I take maximum load, I lose contact with A. With A, yeah. Because when you tip over here, you will be supported. You will support yourself at this point, so you lose contact with B. Okay. While if you have maximum load, then you risk to tip over in clockwise direction. Then you will support yourself at B, and you will lose contact with A. Okay. In this case, they are considering the opposite of us. We are considering zero load. They are considering maximum load. That's why they have opposite scenario. Okay. So if I have a zero load here, I'm risking to turn counterclockwise. So I'm risking to lose contact with B. So RB will be 0. If I put maximum load here, I risk to rotate clockwise. So I support myself on point B, and I am losing contact with A. So I will put them here. For zero load, you have the first extreme condition. You will lose contact with B, so RB is 0. While if you consider maximum load, 18 tons is your maximum load. Since you are working to get the extreme conditions, and you are working in a way to do a design to work in extreme D and WC, which correspond, if you want, to your loss of contact with the ground, okay? So this will correspond to losing contact at A, and then I solve with RA equal to 0. Okay? So here, if I start with the first case scenario, zero load, okay? And since I have the risk of losing contact with B, and RB is 0, then if I write sum of moment about A, I will have only as unknowns WC and D, because RA is passing by A, so it cannot produce any moment about A, okay? So when I do then sum of moment about A, already know RB is 0. And RA is doing a moment about A equal to 0. I'm just left with the moment of WC and the moment of 10 tons about point A. So if I take this line to get my distances, I want to evaluate moments about point A. Okay, so I need this distance. This distance, according to my figure, is D minus this small part here. This small part is given to be 2 feet. Okay, so if I take first the moment of WC about A, I will write sum of moments about A should be 0. My first equation, and if I consider the counterclockwise as positive, I have plus WC times a distance of D minus 2 okay, and then I need to consider now the moment of 10 tons, which is clockwise, so minus 10 times which distance. I take this line and I project. I need the perpendicular, which is this one, okay, this distance, okay, between 10 tons and my point A, according to the figure, it's 3 plus, and this small distance, which is 3, plus this one, which is 2, so it's in total 5. So minus 5 times 10. 5 times 10 equals to 0. These are the only forces doing moment about A. I get a first equation relating WC and D, but I need another equation. This is equation number 1. What will be my equation number 2? My equation number 2 will be summation of
Fy.
moments about B equals 0. No, not for this scenario, for the other scenario. I need another equation relating weight and D. So I will take the second extreme scenario. What is the second extreme scenario? I have maximum full load. If I have a full load of 18 tons, I risk to tip over B. So I will lose contact with A. So RA will be 0. So now if I take the second scenario, I say RA is 0. So now it's of interest for me to do sum of moments about B. So if I do sum of moments about B equals 0, I will get another equation with 2 unknowns, which are WC and D. So now I will end up with 2 equations with 2 unknowns. This will give me what are the values of the counterweight and distance D to work in the extreme conditions. Okay, we'll continue this problem next time. Any question before we stop?
Thank you, doctor.
Welcome. Bye.